Hello everyone, dear students. Today we shall look at a different topic, that is a file system interface. So in this particular topic, basically we will learn about the file system, about the files, file concept, access methods, directory structure, file system mounting, file sharing, and finally protection. Let us see what are the objectives of this particular topic. The first one, to explain the functionalities of file system. Second, to describe the interfaces to the file system. Third, to discuss the file system trade-offs, including the different access methods, file sharing, file locking, and directory structure. Finally, to explore the file system protection. So let us begin with file system. We should know that every operating system or every computer system should have the file system, because in the computer, actually, everything will be stored in the form of file. You take any information, data, program, or any device that is connected to the computer will be stored as a file. So what we call the device file. It means anything we take in the computer system, it will be stored in the form of a file. And a computer system or operating system should be containing a file system. File system basically providing the way through which we can organize the files in the computer system. It means it is providing a mechanism for online storage of or access of both the data and programs of operating system, and all the users of the computer system can use the file system. File system basically consists of two independent parts. First one is the collection of files, each is storing the related data. File is basically storing the related data. Second one is directory structure. It is basically organize and provides information about all the files in the system. Now let us look at the file concept. A computer can store the information in the secondary storage devices like magnetic disk and tapes and optical disk. You know that actually the data or information will be stored in the secondary storage devices like hard disk in the form of file. The operating system abstracts from physical properties of this storage devices to define logical storage unit, that is the file. Actually, the files are mapped by the operating system onto physical devices like secondary storage devices, and it is stored as a contiguous logical address space. A file is named collection of related information that is recorded or stored in the secondary storage devices like hard disk. And there are different types of files. A file can be a data file or program file. Data file is basically holding different type of data. A data file might be containing the numeric data, it is containing the numeric values, or even it may be containing the character data. For example, if you take any text file, it is made up of different characters, so that is called as a character type data file. And even data file might be containing the binary information. So the data file containing numeric, character, binary, and the type of file you can find in the system is a program. So this program can be either system program or application program. Actually, programs are stored in the form of file only. Now let us see about the file structure. Basically, a file basically can be viewed as a collection of bits, words, or bytes. A file is a simple record structure. It may be containing a set of lines. It is having some fixed length, or a file can be of a variable length. And the file can be a formatted document or relocatable load file. Now let us see what are the different file attributes. A file in the operating system or in the file system will be having different attributes. The first one is name. So name is basically used by the user to identify the name. It is basically name of the file. This is the only information which is in the human readable form. Second one is identifier. Every file is assigned with a unique number that is called as a file identifier. So that is used by the file system to identify a particular file uniquely. The third attribute is type, is basically identifying the type of the file, so that whether the file is data file or program file, that will be identified by this particular type. The next one is location. Location is basically a pointer to a file location on the device and to the location of the file on that device. It means we know that actually the files are kept on the device, and the location of that file on the device will be present in this particular attribute. Exactly at what location a file is stored in the device can be identified by this location attribute. The next attribute is the size. It is basically size of the file usually is measured in terms of bytes. Sometimes size can be measured in terms of words or blocks, but most of the time the size of the file can be measured or indicated in terms of bytes only. Protection. So there are some methods so that we can provide protection against reading, writing, and executing. We will discuss in protection later in detail. The next one is date, time, and user identification. So these attributes are basically providing the date and time of the last access, the date and time of last modification, and also the user identification. What is the last access time? So this is the date and time the file has been accessed by the user. What is the date and time of modification? That is the last modification date and time. So this is the modification of the file content done by the user at a time and date. So that is called as the last modification date and time. And also there will be user identification. Okay, here we should know which user has accessed or done modification to the file. That is called as user identification. Now see what are the different file operations. Basically, file is an abstract data type. It is an abstract data type. For example, in C there is a data structure called file, so which is called as an abstract data type. So there are different operations we can perform with respect to file. The first one is create, is basically creation of a new file. One thing you have to remember, all the files must be stored in a directory or folder. Folder is basically providing a space for a different file. Files are grouped into a particular folder or directory. So if you want to create a new file, you must be there in one of the directory file or folder where actually we can create a new file. So there are some system calls we can use it. The operating system like create system call. Create system call maybe taking the file name that you want to create as a parameter, and using that we can create a new. The next operation is read and write. Once a file is created, which and is stored in the directory file, we need to open that file. A file can be opened for two purposes. It can be opened for either reading purpose or writing purpose. So before we can perform read write operation, a file must be opened. For that, in Unix, there is a system call or API that is called as open, which is taking two parameters. The first one is name of the file or path name of the file that you want to open. Second one is open mode. In which mode you want to open? Whether you want to open file in read mode or write mode. If you open file for read mode, then a process or user can read the contents of that particular file. That is called as read operation. So there is something called file pointer that is written by open API system call. If a file is opened successfully, open API is going to return file pointer. So the file pointer is basically called as a file handler it is basically yeah, used as a reference in the file. It will be pointing to some records in the file. Okay, that file pointer can be used to read the contents of the file. So that is the real operation. If the file is open for writing purpose, then new process or user can make the modifications to the file with respect to the file pointer. File pointer is basically giving position within the file. The next operation is reposition within the file. As I already mentioned, file pointer will be giving position within the file and it can be repositioned. Okay, so when we start reading the contents of file pointer will be advancing, it is moving in some direction and it can be repositioned. The file pointer can be reset to any position in the file. It can be reset to the beginning of the file. The next operation is delete. The file can be deleted from the folder or directory. There is some API called MK RMDIR in Unix. Using that we can delete a file. Truncate. So truncate is basically truncating the contents of the file. Suppose that you want to delete the contents of a file. So what we can do, we can delete a file and we can recreate empty file. But it is very expensive. Instead of that, what we can do is keeping the existing file attributes, only we can delete the contents. So that is called as file truncation. So that is there is a system called open and close. So open is the system call for opening a file. It is taking a parameter like fi is basically name of the file that I want to open. So what this open API does or system call does is, so it will search the directory file on the disk for the entry fi or the file fi. If the file is found in that particular directory, then it will be opened with the specific mode. So once we complete the usage of the file, then finally we need to close it. What if there was an API called close, where it is taking a file pointer as parameter, using that we can close the file. Now let us move on to open files. So that is what before we can read the contents of file or before we can write something to the file, we need to open the file. So to open a file, the operating system is providing the different system calls. In Unix, the system called open. I already mentioned that it is taking the two parameters. The first one, the file name or the path name of the file that I want to open. Second one is the file opening mode, read, write, like that. And if the file is successfully opened, it is going to return a file pointer. So file pointer is basically indicating the position in the file. So that is what, once you open a file, you will have this file pointer. This is basically a pointer to last read or write location per process. For different processes, a different file pointer will be maintained for read or write operation. It is basically providing a location for read and write. The next one is file open count. It is basically a counter indicating how many number of times the file is open. So that is called as the open count. How many times the file is opened by process. It is basically called as file open count. The next one is disk location of the file. It is basically providing the information about the location of the file and the secondary storage devices like hard disk. The next one is access rights. This access mode will be given to the different processes for accessing, whether a process has access right like read, write or execute. It means if a process has read access rights, then a process can access a particular file only for reading purpose It cannot be for writing purpose. If a process has a write access, it can perform both read and write. Similarly, a process can be assigned with access right of execute. If a process has got execute right, then it can execute a file. Now let us look at open file locking. So whenever a file is opened within the system with the help of open API, and once the file is opened, it can be used for either reading purpose or writing purpose. So whenever a process or different process want to read a file concurrently, then it must be allowed. So there is something called lock will be imposed on the files. So there are two types of locks, shared lock and exclusive lock. A shared lock is basically called as reader lock. In that, several processes can acquire the reader lock or shared lock concurrently. It means many processes are allowed to read the contents of the same file concurrently. It means two or more processes want to read the contents of the file at the same time, it must be allowed. And whichever process wants to read the contents of the file just acquire a reader lock or shared lock. Why the name is given a shared lock? Because this the contents of a file can be read by a number of processes at the same time. It means a particular file can be shared for reading purpose, and the name is given a shared lock. In the process that wants to read the contents of the file should acquire this particular shared lock, which is also called as reader lock. So in this case, basically, number of processes can acquire this shared lock simultaneously because the many processes are allowed to read the contents of the file at the same time. The second type of lock is called as writer lock or exclusive lock. Only one process at a time is allowed to acquire this particular lock. What is exclusive lock? Exclusively, this lock is acquired by a particular process or one process. It is also called as writer lock. Why only one process is allowed to acquire this particular lock? So, whenever a process acquires exclusive lock or writer lock, then it is modifying the contents of the lock. If one process is modifying the contents of the file, and no other process can either write or read that particular file. So it is called as exclusive lock or writer lock. That is, if one process is acquired exclusive lock, then no other process can either acquire exclusive lock or shared lock on that particular file because that file is modified by one process. And the file lock can be either mandatory or advisory. What do you mean by mandatory? Mandatory means access is denied depending on the lock's health and requested. Advisory means processes can find status of lock and decide what to do. So that is called as advisory lock. Now let us see what are the different file types. Basically in the system, type of file is identified by something called extension. If you take the file name, it is having two parts, name and extension. Name of the file followed by dot, then extension. Extension is basically used to identify the type of file. For example, if you take file type as executable, in Windows operating system, executable file have extension .exe. Even if you take the DOS, it is having the extension as COM. Even it can be bin or it can be none. If you take Unix or Linux, executable file may not have any extension at all. So that is what executable files may not having any extension in systems like Unix. So these executable files are basically containing machine codes, so which can be directly executed by the operating system. The second one is second file type is object. So once you compile a program, the output of compiler will be object file. The object file will be having extension .obj or .co. So these object files are not linked. Only these are compiled and containing machine codes in the hexadecimal form, that is called as object file. The next file type is the source code. So that is basically program written in some language will be stored. So that is called as the source code. For example, if take C programs that have the extension .c, file name .c, C++ in Unix having extension CC, and Windows we are having extension CPP, which is C++, but on Linux or Unix we are having extension of .cc. Java files will have the extension .java and etc. So that is called as source code. The next file type is batch. So batch is basically a set of commands you can execute simultaneously. And the systems like Unix, there is something called shell, uh, which is capable of processing batch. Batch is basically a set of commands are executable in sequence. So there is a command called sh. So using that we can execute a batch file. In Windows there is something called bat. You can create a file with extension .bat. So that is called as batch file containing a set of commands, and it can be executed in the system. The next file type is the text. It is having the extension .txt doc. It is usually containing the text data document. For example, if you create a file in file, it is having extension of .txt, which is containing the text data. Similarly, if you create a file in Microsoft Word or any word processing application, then it is having the extension of .doc. It means a text file basically containing textual data of the documents. Next file type is word processor. So it is basically different word processor formats like WP, text, RTF, and doc. The next file type is library. In the Unix, we have the extension like lib, and Windows we are having the extension of .dll. So that is called as library. Basically, library of routines for programmers will be present in the library file. For example, if you take a C language, there is something called stdio.h. So these are the header files which are present in the library. The next one is print.b. So these are ASCII or binary file in a format for printing or reading. For example, PS is basically PostScript used in Unix for printing or reading. PDF that we know that, and JPG. So these are the file formats we can use for printing or reading. Next one is archive. Archive is basically grouping of grouping of related files in one file. These related files are grouped into one file, and sometimes they are compressed. So that is called as archive. We have different formats like tar, zip, and tar. In Unix or Linux, we make use of tar. In Windows, we make use of zip. So these are the basically formats used to group the files into one, and they are compressed. The next category is multimedia. This containing the audio video information. So we have a different extension like MPEG, MOV, RM, MP3, AVI, MP4. So these are the formats used for multimedia contents. Now let us look at the different access methods. A file can be accessed in three ways. So that is sequential access and direct access. What is sequential access? We access the file contents byte by byte or record by record. So we'll perform the different options like read next, write next. What is read next? Read next is basically reading the next information or the next portion of the file, and automatically a file pointer will be moving to the next location. So similarly, write next. This basically uh, appends contents to the end of the file. So that is what write next operation. Reset. It is basically resetting file pointer to the beginning of the file. And there is something called rewrite. The next access method is direct access. So what is the direct access? Directly we can move to any location in the file and we can read the contents. But then sequential access, we read the contents one after another, byte by byte or record by record, starting from the beginning to end. So we will begin from the first record or the first byte in the file, and we go on reading the contents byte by byte with operations like read next or write next. Whereas in direct access, we can directly move to any location in the file and we can read a file. So in this case, we need to mention a block number. That is what if you take the read operation, it is taking the n as a parameter. So n is basically indicating the block number where exactly we want to read the content. So we'll have to mention the block number of the content in the file. Directly we can go to that particular block and read the contents. The next operation is write. Here also we are mentioning the block number n. So we'll directly move to the block number, specify block number n during the file. Here we can write the contents. And we can position to n. We can move to the block number n, and from the particular block we can access the contents sequentially. So that is position to n. So we can directly access a particular block n, and from that block we can read or write, or even we can read at the contents of the block n. So that is what direct. So this is the pictorial representation of sequential access. The current position in the file is indicated by the file pointer. We will read the contents of the file from the beginning till end. And once we read the contents of the file, a file pointer will be advancing to the next byte or record. So as we can see here, the current position here, and the read and write will be performed from this current position byte by byte or record by record till we reach end of the file. And even we can rewind the current file position. What is rewind? It is reset. The current file position is here, it can be reset to beginning of the file. Again we can begin read or write from the beginning till end, one after another, byte by byte, sequentially from beginning to end. Now let us see the simulation of sequential access on direct access file. So the sequential access operations like reset, read next and write next. Now let us see how these operations will be executed. There is something called the file position. So whenever we execute reset, that file position will be 0. So that is the first byte of the file. So CP is basically a pointer, it is pointing to beginning of the file, that is the first byte of the file. So that is 0. So whenever we execute reset operation, the file pointer or the current position pointer will be reset to beginning of the file, that is 0. It will be reference into first byte of the file. The next operation is read next. So read next basically reading the next byte or record. So after executing the read operation, like read the contents from the current position, so that is from the CP, it is going to read the content. After that, CP will be incremented by 1. It will go to the next record or byte, that is the current position will be incremented by 1. So similarly, so whenever we perform write next operation, the contents from the current position will be modified. So that is a write CP, and CP will be incremented by 1, will go to the next byte or record where we can make the write operation. Now let us look at index and relative file. So there is something called index file is maintained in the system. Index is something like a book index that we are having. It is having two fields. It is the name of the file and logical record number. In the index file, we find two columns here. That is name of the file and logical record number. So logical record number is basically pointing to some relative file in the disk here. So that is what shown here. So it is basically a pointer pointing to some relative file in the disk. So this some space is required for storing the index file in the system. So that is overhead. Now let us see directory structure. So let us recall what is directory. So directory is basically a collection of related files. Files are grouped into a directory or folder. In Unix or Linux we call it as a directory file, but in Windows we call it as folder. Folder is basically a directory file is basically containing different files. Different related files are grouped into a directory or a folder. Now let us see what is the directory structure in the system. So a directory file or a folder is maintaining a different pointers to files. It is basically a collection of nodes containing information about the files. So as you can see in the diagram here, so these are the different pointers pointing to files. So these files are basically grouped into a directory or folder. Both the directory structure and the files will be stored on the disk. Now let us see what is the disk structure, how the disk will be structured. Usually we know that the hard disk or magnetic disk will be divided into number of partitions. Like if you take Windows operating system, will have the different partitions named as C drive, D drive, E drive, F drive, so on. C drive is basically called as primary partition, where actually the operating system will be stored. And there will be extended partitions which are named as D, E, F, and A and B are basically indicated other disks like floppy disk. What I mean to say is disk can be divided into number of partitions. Disk or partitions can be either RAID, which provides protection against failure. A disk partition can be used as raw partition without containing any file, or a disk partition can be formatted with the file system. For example, if you want to create a partition under Windows, it must be formatted with some file system like NTFS. NTFS is the file system used in Windows. It stands for New Technology File System. File partition can be used as a raw. If it is raw, it means it doesn't have any file system. But most of the time, a partition must be formatted with a particular file system. It is compulsory. Partitions are also known as mini disks or slices. An entity containing file system known as volume. Each volume containing file system also tracks the file system's information in a device directory or volume table of contents. Now let us see a typical file system organization. As I already mentioned, a disk can be divided into different partitions. So in this particular diagram, there are three disks here: disk 1, disk 2, disk 3. And disk 1 having two partitions. It is divided into two partitions, partition A and partition B. And each partition will be formatted with some file system, and it is holding some files. And there is something called directory or directory folder. So this directory basically maintaining the index of the different files stored in this particular partition. Okay, partition A having a set of files. The information of these files will be stored in the directory along with the index. And if you want to access any file, you need to go to a particular directory. You should get the index. Then we can locate a particular file in the partition. So similarly, in the same disk, another partition has been created, that is partition B. It is having its own files and directory. So this one is partition. This one is divided into two partitions, partition A and partition B. In this particular diagram, two disks have been combined into one partition, that is partition C. So in this diagram, a single disk is divided into two partitions, part A, part B, partition A, partition B. But in this diagram, two disks have been merged into or combined into a single partition called partition C, and there will be files present in this 2 and this 3, and their information or links are stored in a directory file. Now let us see what are the different operations performed in the directory file. The first one is search for a file. Suppose that if you want to search for a file, then we need to visit directory file. In the directory file, there is something called index is maintained, that is name of the file and its location, and the disk will be maintained. And using that, we can locate a particular file on the disk. Second operation is create file. If you want to create a file, then it must be created in the directory. Delete a file. We can delete a file from the directory. That is what delete file operation. List a directory. A contents of a directory file can be listed. There is a command called ls in Unix. Ls stands for the list a directory command. In DOS, there is a command called dir, that is going to list the contents of directory file. Rename file. A file that is present in the directory can be renamed. Its name can be changed. That is rename operation. Traverse the file system. We can traverse through a directory or subdirectories in the file system. That is what traversing the file system. Next one, organize the directory to obtain efficiency. Efficiency is basically locating a file quickly. That is, searching a file in the directory must be very fast. So that is called as efficiency. And the naming must be convenient to user. It means that two users can have same name for different files. So two different users can create a file with the same name, and they must be kept in two different directories. A same file can have several different names. So there is something called alias. Alias is what duplicate names. Physically, there is only one file name, and there will be many different names assigned to that particular single file. That is called as alias. And directory must be providing grouping. So that is the logical grouping of the files by different properties. For example, all Java programs can be grouped into one particular directory or folder. All games or gaming programs can be put into a particular folder or directory. So that is grouping is provided by the directory file. Efficiency, naming and grouping. Now let us look at different directory structures. First one is single level directory. In this particular structure, all the files in the system are stored into same directory file. That is shown in this particular diagram. So these are basically pointers pointing to location within the file. So these are basically called as file pointers. A directory maintaining the name and its index or location. Okay, in this particular structure, all the files in the system are put into only one directory. Do you know what is the problem with this particular structure? There can be naming problem. Here, two different users can have the files with the same name, but that leads to collision in this particular structure because all the files will be stored in the same directory, and if two processes creates a file with the same name, that leads to name collision. So which is not allowed here. So that is called a naming problem, and also there is a grouping problem. So we cannot have the grouping the files with the same name. So that is what grouping problem occurs in single level directory. To solve this problem, we can go for two level directory. So separate directory is maintained for each user. Okay, so there is something called a master directory file. So it is basically containing different directories for different users. So like user 1, user 2, user 3, user 4. User 1 will be having this particular directory, user 2 will be having a different directory file, user 3 or user 4 will be having their own different directories. So what is the benefit of two level directory? Where actually for every user there is a different directory file is maintained. It means two different users can have the same file names which are stored in two different directories. For example, you can see here user 1 will be having a file name as A, and user 2 can have the same name, which was not allowed in the single level directory because all the files were stored in the same directory. But here, user wise a different directory file is maintained. A file related to a particular user are put into a separate directory, and two different users can have the same file name because they are kept in two different directories. For example, as I mentioned already, the file A is being duplicated among the different users here. So which is allowed here because if you look at this particular A for user 1, its directory is different, and if you look at this A for user 2, its directory is different. So it means user 1 and user 2 can have the same file A, so they are kept in two different files. So let us see what are the benefits we get out of two level directory. Okay. So a particular file in two level directory can be accessed with the help of path name, and we can have the same file name for different users, and with providing efficient searching. The searching will be very efficient because it is based on total user, but it doesn't provide a grouping capability. So that is one of the limitations we have it in two level directory structure. Now let us move to the next one, pre-structured directory. Actually, the directories or the files are organized like a tree. There, you know that in a tree there is something called root node. So there is a root directory that is containing pointers to the subdirectories. So the subdirectories can be indicated as nodes of a tree. Even a node can be a file. Okay, it means in the pre-structured directory, the files are organized like a tree. And the file directories will be the nodes. There's something called root node, and other nodes will be the subdirectories of files. And let us see what are the benefits of pre-structured directories. It provides efficient searching. We know that the information can be searched efficiently in case of tree. So there are some different traversal techniques to evaluate like pre-order, in-order, post-order. We have these three traversal techniques. Using them, we can easily search any file. So this keep providing efficient searching. The next one is grouping capability. Grouping of the files will be very easy in case of pre-structured directory. And the tree enables current directory. It is something called as current working directory for the user. For each and every user, there is a directory assigned that is called as current working directory. That particular user will be working that particular directory. For example, so this is the path name for the directory. Okay, there is a command on Unix called cd and for change directory. So the path name will begin with something for / that is called as the root directory in Unix. So that root directory will have the subdirectory called spell. The spell directory will be having the subdirectory called mail. Mail will be having a program. So this is the path name of the particular file program. It will begin with the root directory, then its subdirectory spell, and mail is the subdirectory within the spell, and within the mail will find the program. So cd can change the directory to program. Okay, where actually user will be working on that particular directory, that is called as current working directory. And path name can be either absolute path name or relative path name. The absolute path name always begins at the root and follows a path down to the specified file, giving the directory names on the path. For example, we'll begin with the root node here, that is in Unix, the root node is indicated by // then you will have the spell /mail /prt/first. Okay, so this is what is absolute path name. Absolute path name always begins at the root, then we go with the subdirectories, and finally we reach a particular file. So that is called as absolute path name. So this is one example for absolute path name. So we begin with the root node that is indicated as a / in Unix. So this is we begin with the root node, then spell /mail /program. So this is what absolute path name. Relative path name basically defines path from the current working directory. By default, path name is relating to current working directory, that is called as relative file name. Creating a new file is done in current working directory. If you want to create a new file, by default it will be placed in the current working directory. And from the current working directory, we can delete a file using the command called rm in Unix. The syntax of rm is very simple: rm followed by file name that you want to delete. The specified file name will be deleted from the current working directory if it is available. If the specified file is not exist, it is going to be removed. Now let us see how to create a new directory file and its in the current working directory. For that, we can make use of a command on Unix called mkdir. Mkdir stands for make directory. So it takes a directory name that you want to create as a parameter. Mkdir command is going to create a specified directory in the current working directory. For example, if the current working directory is mail, and if you execute a command called mkdir count, so count is the sub directory of sub folder that you want to create under mail, so that is indicated here. So mail is basically the main directory. Under that we have the different directories like proc, copy, prt, exp, count. So these are the sub directories using the mail. And if you delete the mail, then the entire subtree rooted by mail will be deleted. So these are the subfolders or subdirectories under mail. If you delete mail, so this entire tree will be deleted, including its subdirectories. Okay, the new directory subdirectory can be created using mkdir. A directory file can be removed using rmdir. A particular file in the directory can be removed from rm. The new file can be created in the current working directory. So let us move to the next one, acyclic graph directories. Basically, directory is represented as an acyclic graph. Acyclic graph should not contain any cycles. It is basically providing shared subdirectories and files. So as we can see this particular diagram, here the directives and files are organized in the form of graph which doesn't contain any cycles. If you look at this particular node here, so this is main directory that is indicated as the root node. So these are the subdirectories in the root node. Okay, so there is something called DICT directory which is containing these directories like list, all, w, count, and spell is also having subdirectories like count, words, list here. So there is some file, so that is being shared by uh, count here. So one directory count is present in this folder. So this directory, another count is present in this folder, and both are sharing. So subdirectories can be shared in case of cyclic graph directory structure. So that is one of the main advantage we get. And two different names, that is aliasing. Physically there is only one file, but there will be two different names given to that particular file. So that is called as aliasing. Now let us see about dangling pointer. So if the DICT directory deletes list, then there is a possibility of dangling pointer. Let us see what is that. Okay, so DICT deletes list, then there is an entry pointer to this particular file, so that is called as dangling pointer. Now let us see how to work from the dangling pointer. See, DICT is a what you can say main directory. If it deletes a subdirectory list, so list is having a pointer to this particular file. If DICT deletes list, okay, there is an empty pointer referring to this particular file. It is called as dangling pointer. Now let us see how avoid this dangling pointer. So we can have the back pointers, so that so we can delete all pointers. Variable size record problem can be solved. It means from this we can have a back pointer to the root node or its parent node. So that is how we can solve the dangling pointers. And back pointers using daisy chain organization. So we can use a technology called daisy chain through back pointers. The next one is the general graph directory. So here also actually the directories, subdirectories and files are organized like a graph, but it contains cycles.